In the endless reaches of the universe, Earth seems unique. It's a planet shaped and molded by life. A planet that 6 billion people call home today. But when it was born, some 4.5 billion years ago, Earth was a violent place. So hostile, it's hard to believe life could ever begin here. Covered in lava and smothered in noxious gases, Earth was a planet under siege.
If you were a human going back into time and trying to stand on the early Earth, it would be just like visiting a planet that was not your own.
This was a hazardous world, no doubt about that. If you were located in the wrong place at the wrong moment, you were simply vaporized.
It was a planet plagued by catastrophe. If you condense all of Earth's history to just 24 hours, then only minutes after it formed, the entire globe melted and reformed. Then, to make matters worse, another planet about the size of Mars slammed into Earth. A cataclysm that created our moon. But soon after these disastrous beginnings, the most radical transformation of all time hit the planet. The origin of life. So how did life begin? Well, over the years, people have come up with some pretty creative answers to this question. One of my favorites comes from a 17th century scientist who wrote down a recipe for creating life from scratch. Let's see. It says here, take a dirty garment, place it in a vessel. Next, add wheat. Then, according to the recipe, after fermenting for 21 days, mice will appear, fully formed. Of course, we all know that life doesn't form this way. But at some point in Earth's early years, life did emerge out of non-living ingredients. And for clues to the real recipe of life, we have to go back some 4 billion years to a time when Earth was nothing like the planet we know today.
When we think of early Earth, we must recognize it was not a Garden of Eden. There were no clear blue oceans. There was no clear water. There were no plants. There was no life at all.
The young sun was weaker than it is today. And its light barely penetrated the atmosphere of carbon dioxide, spiked with the pungent fumes of hydrogen sulfide.
Since the atmosphere was thicker and dominated by CO2, the Earth had a reddish tinge to it. It didn't have the familiar blue sky. The oceans would have had an olive green color rather than our familiar blue color.
For about the first 600 million years, comets and asteroids pounded our planet. A time known as the heavy bombardment. These interplanetary missiles measured up to 300 miles across. Their impacts vaporized Earth's oceans and melted its crust. With its extreme temperatures and toxic rain, seemingly nothing could survive here. But we now think that in this hellish environment, life first took hold. And today, hidden away in remote corners of our planet, conditions that in some ways resemble the extremes of early Earth can still be found. Penny Boston and Diana Northup are microbiologists on an expedition to investigate how life can survive in those harsh surroundings. Buried in the depths of this tropical rainforest is a cave called Cueva de Villaluz. Located in southern Mexico, it's an underground world laced with hydrogen sulfide, a foul-smelling gas that was present on Earth some 4 billion years ago.
These relic or antique environments like Cueva de Villaluz offer the same kinds of environments that we would have found on early Earth, and we're hoping to get clues to work backwards from those. As you approach the cave, you begin to get these faint whiffs of the rotten egg smell, and as you get closer, this becomes more intense.
Hydrogen sulfide can be extremely poisonous, so the scientists have to wear gas masks inside the cave and carefully test them for leaks.
No leak.
Have you got everything in there?
I think I got everything. Yeah.
At the levels at which humans can't live very long in hydrogen sulfide, you don't smell it at all. And it will just simply cause you to go unconscious and die very quickly.
But can any other forms of life survive in the deep recesses of the cave, so toxic to humans? Here, hydrogen sulfide, an invisible gas, escapes from the underground springs, reacts with oxygen in the water, and coats the cave with sulfuric acid.
The longer it sits there on the walls, the more acid it becomes, and so eventually by the time the drop is falling on you, it's a very, very acid environment.
The slime layer feels pretty thick today.
It's very fatiguing, and even with the protective masks that we have, we pick up loads of toxic gas through our skins and perhaps through tiny leaks.
Oh, get them out of those sweat tights to your left.
Amazingly, despite the extreme conditions, it appears that life is thriving inside the cave. It comes in a strange package, colonies of single-celled bacteria that form slimy drips scientists call snotites.
The snotites are drippy, gooey, mucousy formations that look like stalactites, and that's why they were called snotites, but because they resemble strings of snot. We believe that the snotty, gooey stuff is to protect them against the extreme acidity, because when we measure the drips on the snotites, they are as extreme as battery acid. And so while we find that daunting, this is where they thrive.
Bacteria are among the most primitive and most common organisms on Earth. Like all forms of life, they grow, adapt to their environment, and reproduce. Inside each single-celled bacterium is a molecule of DNA, the code of life, which allows them to multiply. There are millions of bacteria in each snotite. And down in the underground streams, Penny Boston has found different kinds of bacteria in slimy clumps she calls phlegm balls. In fact, the cave is home to a huge number of bacterial colonies. And astonishingly, instead of being poisoned by the hydrogen sulfide, these bacteria depend on it for their survival.
They take the hydrogen sulfide and they get chemical energy out of it. It doesn't poison them. It's home sweet home for them. And this is a pretty new finding for these organisms.
Conditions on early Earth may have been far worse, But these bacteria suggest that primitive life could have thrived in extremely hostile environments. But where did the very first life come from?